Okay, so in regarding these triangles, they're called Pascal's triangles. This is lesson 10-2, okay? And it says the definition of Pascal's triangle says let n and r be integers where r is in between 0 and n, okay? It's a number in between them. Pascal's triangle is a two-dimensional sequence in which the r plus 1 is term, so if you have 4 plus 1 is 5, the fifth term in the row n is using the counting function that we used yesterday, the combination function, okay? Okay, so I know you weren't here yesterday, but okay. So it says find the first 4 terms in row 9, and this is what you're going to do. Since we don't have 9 on the screen, we actually have to use the terms here. I'm going to expand the screen a little bit so you can see it a little bit closer up. Right here. So we're going to use the first 4 terms. So let's write this out. We have a row, it's row 9. It's going to be 9c of 0 is the first term. Okay. The second term is going to be 9c of 1. Okay. The third term is going to be 9c of 2. And the third term is going to be, or fourth term is going to be 9c of 3. So we need to calculate those. Being that we can't just look at it on the table, we're going to actually use our formula from yesterday. And so the top is going to be 9 factorial over 9 minus 0 factorial, which is just 9, and then 0 factorial. Okay? So that equals 1. Okay? So we know the first term is going to equal 1. We already discovered that pattern when we were looking at the patterns a few minutes ago. The first term in every row is 1. What do you guys think the second term is going to be in this row? 9. It should equal 9. So let's see if we get that. If we put in 9 factorial over 9 minus 1, which will be 8 factorial, and then we'll have 1 factorial here. If you put that in your calculator, guess what you get?
Where'd you get 8?
Because 9 minus 1. Remember that our n of c of r, like this?
No, I don't know. Just don't.
Okay, so I'm going to show you the formula. It goes like this. It is n factorial over n minus r factorial, and then r factorial.
Factorials when you have.
Okay, so this one is going to be 9 factorial of 9 minus 2,
So
7 factorial, and then 2 factorial. Okay, and if you have a factorial button in your calculator, you can put it in. If you're not, you're just going to have to expand it. So this should be 36.
But how do I know?
Because I expanded it yesterday.
Okay, expanding it.
So if I were to expand one of them, I'm going to show you.
9 times 8 over.
9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
Yeah, but I have to cross out 7, 6, 5, 4.
Yep, you can do that. 7 factorial, so all this will cross out, right?
Yeah.
And then you still have 2 factorial, which will be 2 times 1.
Oh, okay, so then I should do 9 times 8 times 2 times 1.
Yeah, 9 times 8 divided by 2 times 1. Okay?
What's 9 times 8 again?
72. Okay, so this one right here is going to be 9 factorial over 6 factorial, 3 factorial. The 6 will cancel, so 987. Yeah, divided by, no, but 3, yeah, I see what you're saying, divided by 6, yeah. Okay, so that would equal 84.
And then it'll go 36, 9, 1. Oh no, we just keep going up.
Yeah, you could go all the way up to 9.
Okay.
Okay? So now let's do the same thing for B. I'm going to give you guys a second to try it on your own. Okay? So go for that.
Like a week.
Okay, so we're looking at row 20 now. So we're going to do
Can I do it?
20 of C. Yep.
Can I
0. You want to come do it?
Yeah.
Okay.
Mona, you weren't even here. Okay, but I understand this.
20 of C of 1.
I ain't gotta be here.
20 of C of 2. 20 of C of 3. So Monet, take it over.
You guys are just haters because you don't know it. How about that?
Yeah, I got it. I got it. You're a hater.
How am I hating on y'all?
It's recording, by the way.
Oh, what up, peeps?
equals 10?
No, it equals 1.
I thought 20 over 20 is 1.
Uh-oh, that didn't
20
really...
factorial over 20 factorial is still 1.
Oh, wait, 19. This is hard to write on it.
Yeah, you get used to it. That's why you guys make fun of my writing all the time. Well, that's why. It's not that easy.
That's not that bad.
Receivers, not that you have bad handwriting, sometimes you just make really funny mistakes. Like Lug. Lug, whatever. I have a picture of it.
What?
Remember she wrote Lug instead of log. She's like, Lug. She thought it was really funny.
I don't remember.
I think I forgot my calculator here again.
Uh-oh.
No, I didn't. No, I didn't. No, I didn't.
There you go.
And
I'm right.
Yep.
Okay.
See? I thought we had her know. Guys, my sister just liked my Instagram.
Very good. Good job, Monet. That's right.
Thanks.
So we already discussed some of these because you guys were so observant that you noticed them already. But it already says that the first and last terms of each row is 1, are ones. Can't talk today. So for each whole number, if I were to put this in C sub 0, you're going to have a number 1. So go back to our little triangle here. You can see that all ones right there. Okay?
So you say like C or 2C0 equals 2C2?
Yeah.
Okay.
Yep. So it's saying the first and the last are equal to 1.
Is that your dog?
Yes.
What's the name?
Bimmy. Okay, the second and next to last terms in the nth row are always equal to n. Okay? So for each whole number, n, choose 1, and n, choose the one next to the last, which is n minus 1, you're going to have n. So, like I said earlier, if we go back to our little triangle real quick, I'll just swing back real quick. Notice that here we have 3 and 3. That's the second and the next to last. 4 is the second, 4 is next to last. 5 is the second, 5 is next to last. Okay? All right. So that's the pattern that we see. Now it also says, number 3, each row is symmetric. What does it mean to be symmetric again?
Mirror.
Yeah, they're mirror images. Okay? For each whole number n. And then it says the sum of the terms in row n is 2n. Okay? The sum of the terms in row n is 2 times n.
Not for the first one.
That. Okay, so when I was writing it from the book, I was just writing what it said, and I didn't pay attention to it. So it is 2 to the nth, okay? For each whole number n. So the sum is 2 to the nth. Okay, so now,
Oh, 2 to the end?
yeah, not 2 times n, but 2 to the nth. So the first one tells us we have to do a proof. And I know how much you guys love geometry and want to go back and do proofs, but this is not that hard. Okay, so what we're going to do is prove that the second and next to last terms of the nth row equals n. Now all we have to do is notice that the second entry in any row is in choose 1, right? Doesn't matter what row it is, it's going to be that row number, choose 1. Okay? So let's just put this into our formula. N choose 1 is the same thing as saying n factorial over n minus 1 factorial and 1 factorial, correct? Okay. So if I were to write this out, I can keep writing out like n times n minus 1 times n minus 2 and so on, right? But so on I'm going to use with the factorial. So I have that on top now. And then I have n minus 1 on the bottom, and then I have 1. Notice what I can cancel out.
The n minus 1?
Yeah, the n minus 1 factorial. So I am left with just n over 1 factorial, which is n. So I just proved that the second term in every row is n.
Whoa. Oh my gosh. Somehow this is weird, but whatever.
Okay? Now I can also prove that the next to last number in every row is n. I can do that by doing this. It's going to be n factorial. And then notice I'm always taking the n minus the n minus 1. So it'll be n minus 1 factorial. And then I can have n minus 1 factorial.
What are you proving?
I'm proving that the second to last one is also n. Okay? So look, I can do n times n minus 1. Okay? Now I have n minus n. What happens to those two n's? They cancel. This n becomes a positive, right? So I have 1 factorial and n minus 1 factorial. And what can I cancel out? Yeah, so once again, I can prove to you by using symbols that the second to last is always the same as the row number.
Wait, the first one we did is the second or first?
The second number in the row is always equal to the row number, and then next to last is always the row number.
Okay.
Okay. So, example 2b, I'm supposed to prove to you that the third term in the nth row is equal to n times n minus 1 over 2. Okay? So this one is really not all that hard either. So it's just saying prove this is equal to this right here. Okay? So if I put that in my formula, I have n factorial over n minus 2 factorial and 2 factorial, correct?
I don't get really what you're doing.
Okay, so what I'm doing is just putting this into our formula for combinations, right? We always, if this were 9, it would be 9 on top, correct? And then 9 minus 2 right here, okay? But I'm just using the letter, okay? That's what's throwing people out. Okay, so now I'm trying to prove that the circled portion, this is going to equal this. So, what I can do is take this n factorial.
Oh, and then do n minus 1 and n minus 2?
Yep, and it keeps going, so I'm just going to put factorial there. And then on the bottom, I have an n minus 2 factorial, and I still have a 2 factorial. So what happens to the n minus 2 factorials?
Cross out.
They cross out. Okay?
Then you have n times n minus 1.
Yep. And then 2 factorial is just 2.
Wait, so the factorial goes away?
Yeah, because 2 times 1 is 2.
Put on the top? Is it
Yes,
factorial?
because we took it all the way down to n minus 2 factorial, and then we canceled them.
Oh.
Yep.
And how did the 2 factorial go?
Because it's 2 times 1.
It's just 2.
2 times 1 is 2.
What do you mean 2 times 1?
Well, what's 2 factorial?
Oh.
Okay?
That's dumb.
Okay. So now, look at number 5. Says, for each element is the sum of the 2 elements nearest it in the preceding row. Okay? So I want to show you that, because actually Annalise showed us that earlier.
What did I show you?
This, right here. Okay, notice that 1 plus 4 is
You're judging.
5. 4 plus 6 is 10. 6 plus 4 is 10. So that's all that's saying, is that the numbers preceding it above are adding up to make that number. Okay? That's what rule number 5 is telling us. All right? Yes. Okay, so it says, example 3, use properties 1, 3, and 5 to construct row 7 of Pascal's triangle. Okay, well, we have row 6. Do we not? Here's row 6. How would I make row 7? It's going to be a 1 and a 7 for sure, and then a 7 and a 1.
And then you add.
Then I can add these two.
21.
Yep, 21,
And then
35.
35.
What's these two added? 35 again,
And then 21.
and then 21. So that's the last example.
Wait, I can.
So it just asked us to build row 7 based on what we know.